For each of the following plane stress loading, calculate the factor of safety based on maximum shear stress theory and distortion energy theory. The component under loading has a yield strength of 60 kilo psi. This example is an extension of another example that we discussed in a different lesson. I'll put its link up here so you can watch it later. In part A, we have the following plane stress. Sigma x equals 60, sigma y equals 40, and tau xy equals 10. First, we find sigma A and sigma B by substituting sigma x, sigma y, and tau xy. We have a case where both sigma A and sigma B are positive, which results in sigma 1 equals 64.1, sigma 2 equals 35.9, and sigma 3 equals 0. We can now calculate the factor of safety based on the maximum shear stress theory. This factor of safety, which is smaller than 1, indicates failure due to yielding. We also calculate the factor of safety based on the distortion energy theory. This theory predicts no yield failure since the factor of safety is larger than 1. This is an interesting case since one theory predicts failure and another one predicts no failure, even though within a small margin. This, however, is not unexpected because the maximum shear stress theory is more conservative and therefore predicts a smaller factor of safety compared to the distortion energy theory. For this loading scenario, we have sigma x equals 60, sigma y equals negative 40, and tau xy equals 10. First, we find sigma A and sigma B. This is a case where we have sigma A positive and sigma B negative. This results in sigma 1 equals plus 60.9, sigma 2 equals 0, and sigma 3 equals minus 40.9. Factor of safety based on the maximum shear stress theory is calculated. This factor of safety, which is smaller than 1, indicates yielding failure. Factor of safety based on the distortion energy theory is also calculated. This theory predicts failure as well. As discussed before, the maximum shear stress theory predicted a smaller factor of safety compared to the distortion energy theory for the same loading scenario applied to the same component because it is more conservative. In part C, we have the following plane stress. Sigma x equals negative 60, sigma y equals negative 40, and tau xy equals 10. First, we find sigma A and sigma B by substituting sigma x, sigma y, and tau xy. This is a case where both sigma A and sigma B are negative. This results in sigma 1 equals 0, sigma 2 equals negative 35.9, and sigma 3 equals minus 64.1. Factor of safety based on the maximum shear stress theory is found here. This factor of safety predicts failure due to yielding, and the distortion energy theory predicts the factor of safety using its corresponding equation. This theory predicts no yielding failure.